Okay, so this is Jelly Bean Lesson 4, and it's entitled What Raggy Taught Fred. I dressed that little Raggy doll up a little bit, put a little tutu on him. Isn't that cute? So Fred was standing at the edge of the stage, and he watched the 3-year-old that had run up on stage stick a giant pacifier in her Raggy doll's mouth. And she turned to Fred and she said, "You know, the pacifier keeps Raggy from crying." And Fred thought about his own doll. This is Fred's doll, and his name is Kingy. And believe it or not, you can buy these dolls. Isn't that funny? Should I buy you each a Kingy doll? Now, Fred realized something about Kingy that he really hadn't thought about before, because he's had Kingy for 5 years, and now Kingy was an internationally recognized artist, and he expressed opinions about lots of things, including which pets Fred should own. Do you believe that? Do you think that a doll could do that? Kind of weird, huh? But then again, Fred's a professor and he's only 5 years old. What Fred realized, though, is that some dolls grow up. What? Don't know. He wondered, why had no one ever thought about that before? No book he'd ever read mentioned that dolls can grow up. Nobody he ever heard talk about dolls had talked about them growing up. Fred was flabbergasted, and that is a really great word, flabbergasted. It means overcome with amusement, bowled over, surprised, astounded. Are you flabbergasted at something? Now Fred realized that the greatest lesson he had learned in life is that he still has a lot to learn. And that's the most important thing, is to always realize from now until you're 100 years old that there's always something more that you can learn. So what I want to teach you today is how to cast out nines. It looks like they're fishing for nines, right? Something like that. And you can read the little cartoon there. The blue guy says, "I got another bite." I don't know. Third bass? Again, how many fish is that? A little silly cartoon, but we're going to learn how to do what this says here, casting out nines. So you can take any 9, say 873. You add the digits 8 plus the 7 plus the 3, and you add them together and you get 18. And then you take the 1 and the 8, you do 1 plus 8 equals 9. So now you have a single digit. So we went from 3 digits to 2 digits to just one single digit. So casting out nines lets you check any multiplication answer. Isn't that really cool? You could do the largest number of multiplication ever, and the way that you casting out nines is a way to check it very quickly and easy to see if your answer comes out right. So suppose someone tells you that 83,954 times 6,728 equals 564,842,712. And you're like, I have no earthly idea. That's such a big problem. Well, we can cast out the numbers, the nines, and we can check to see if the answer is correct. And we can do that by looking at what the numbers that we multiplied here, and casting out the nines from that, and then casting out the nines from the answer. So we're going to do 2 different processes here. So let's look at the first number that we're multiplying by, 83,954, and we just change this whole number. We just add little plus signs between each number, 8 plus 3 plus 9 plus 5 plus 4. We add those together and we get 29, and we have to keep casting out until we get just one digit. So 29 is 2 digits, so we do 2 plus 9 and we get 11. That's still 2 digits, so we do 1 plus 1 and that equals 2. Okay, now we take the second number because the multiplication problem was 83,954 times 6,728. And so now we do the 6,728 and we do 6 plus 7 plus 2 plus 5, we get 23. That's 2 digits. We do 2 plus 3, that equals 5, 1 digit. So now we have 2 and we have a 5 for And the problem originally was, as you recall, just not to get anybody confused, 83,954 times 6,728. So now we've cast out nines in the numbers we were multiplying together. We have to cast out nines from our answer, which was, let me write it down here. 12, okay. And this, even doing this problem on a lot of the little calculators you had, it can't even hold it because it just comes out too big. So let's see what we got. We're going to add. Okay, so here's our big number, and then all we are doing is taking our gigantic number here, putting plus signs between every single one of those, turn it into this big, humongous problem, and we end up with 39. That's 2 digits, so we do 3 plus 9 equals 12, still 2 digits. 1 plus 2 equals 3. Now, if you remember, if you go back to my last screen, we ended up with a 2 and a 5. Or 2, let's see. So our answer from the previous screen, we ended up with a 5 and a 2. 5 times 2 equals 10. 10 is 1 plus 0, which equals a 1. And so that does not equal that. So our answer, this gigantic answer up here, is wrong. So I know it feels kind of complicated, but this is really a super magical way of seeing if a hard multiplication problem, that if you did it right, casting out nines will catch 90% of your errors if you do it. Now, you could always check something with, a calculator, that would tell you, but so if I multiply it out, and it's really hard to be neat using this squishy stylus that I have to write with, but you can see this was how, when I multiplied out what my answer is, this was the answer that I had before, or actually the book had, I didn't do it, but and we can see that we were wrong right here, that one digit was wrong because it should have been a 5. So when we cast out the nines after we did a multiplication, we could see we had a problem. Now, in Fred's advanced algebra class, he would amaze his students by showing them how to get the answer to 7 to the 1,000th power in 3 steps. So 7 is raised to the 1,000th power, okay, 1,000th power in this case, which is, so 7 to the 1,000th power, look at all those sevens that you would have to do. It would just be so many. It would take you hours, several hours to do it with a calculator and a month to do it with paper and pencil, according to Fred. But you can actually do it, excuse me, in 3 steps. Step 1 is to take what's called the log of 7, multiply by 1,000, and then take the antilog. Now, I know what you're saying, that this makes 0 sense. The log of something, the antilog. Okay, so I need to show you how to do this because we need to use it with the scientific calculator that I have. So I'll do it on the board for you, so ask me. But it's kind of a flabbergasting thing, yeah? Math is exciting. So now it is your turn to play. Ask me for the handout and the Oak Meadow sheet. Have fun.